we have seen some of the properties of gases. Now the behavior of gases can be defined in terms of three physical parameters. Those three physical parameters are volume, pressure, and temperature. Let's see each individually. Volume. Volume of a gas is defined as the space occupied by fixed mass of gas. Let's see this experiment. So as the pump is pressed once, it releases 2 grams of gas and it takes up the space of this glass or this smaller container. So in this case, the volume of gas is the space taken up by the gas in this small container by a fixed mass of gas, which is 2 grams. Now, if the same amount of gas is released in the bigger container, so as same amount of gas is released, you observe that 2 grams of gas is released this time as well. But in this case, it occupies the space available by the bigger container. That means gases do not have a particular or definite volume. They take up the entire volume of the container. In the first case, the amount of gas was definite, which is 2 grams, and the gas occupied this space, that is the space of the smaller container. So this is the volume of the gas. In the second case, again, a definite amount of gas, which is 2 grams, occupied the entire space available in the bigger container. So in this case, this is the volume of the gas. And the volume of gas can be measured in different units. It can be liters, centimeter cube, or decimeter cube. The particles of gases are always in a state of constant motion. As they are moving, they collide with one another and with the walls of the container in which they are enclosed. So as they collide with the walls, they exert force on the walls of the container, and this force per unit area is known as pressure. So the pressure of a gas is defined as the force exerted by the bombardment of gas molecules on the walls of a container per unit area of the container. So as the gas particles are in a state of constant motion, they collide with one another and with the walls of the room. So as they collide with the walls of the container or the room, they exert force on the walls. So this force per unit area is known as pressure. Now this pressure is defined by the force exerted, and this force is exerted as the molecules are colliding with the walls. So this collision of the molecules can also be measured in terms of the number of hits per unit time. So pressure can be defined in two ways. It is force per unit area, but this force is because of the collision of the molecules with the walls. So it is also defined in terms of number of hits of the molecules per unit time. So pressure also can be measured in different units like millimeters of mercury, atmosphere, or Pascal. Temperature, the third physical parameter which defines the behavior of gases. This is the degree of hotness of the gas. It is measured in units like degrees Celsius. We know that temperature is also the measure of kinetic energy possessed by the molecule. So this degree of hotness, which is temperature, can also be expressed as the kinetic energy possessed by the molecules. If we compare the three states, that is solids, liquids, and gases, we know in case of gases, the particles are moving faster as compared to liquids and solids. So the kinetic energy of gases is the maximum. And the kinetic energy of solids is minimum. So if we compare the three states of matter, gases have the maximum kinetic energy and solids have the minimum kinetic energy. We've seen before that as temperature increases, that is, if we provide heat energy to the particles, that increases the kinetic energy of the particles. And there's a direct relationship between the kinetic energy and the speed. So as the kinetic energy of particles increases, the speed of the particles increases. Similarly, we have the vice versa case. If the temperature decreases, that is, if we extract heat energy from the particles, their kinetic energy decreases. And as the kinetic energy decreases, the speed of the particles decreases. This means that if we decrease the temperature, the speed of the particles also decrease. Gases can also have negative temperatures. Liquid nitrogen, it has a boiling point of minus 195.8 degrees Celsius. This means liquid nitrogen, it changes into the gaseous state at minus 195.8 degrees Celsius. Also, gaseous nitrogen changes back to the liquid state at minus 195.8 degrees Celsius. So, gases can have negative temperatures. So, is any temperature possible at which gases have zero speed? We know as temperature decreases, the speed of the particles decreases. So, is there any temperature which is possible at which the speed of the particles becomes zero? Such a temperature was defined by Lord Kelvin. He formulated a scale of temperature known as Kelvin scale or absolute scale of temperature. And in this scale of temperature, he defined a value known as absolute zero. According to Lord Kelvin, this is the temperature at which all molecular motions cease. This means the particles stop moving. As they stop moving, the speed of the particles becomes zero. So this temperature, which is absolute zero, was defined by Lord Kelvin as the temperature at which all the molecular motions cease. So he gave his scale known as the Kelvin scale. This can be compared to a Celsius scale. So the 0 Kelvin at the Kelvin scale, this is the temperature known as absolute zero. This is the temperature at which all molecular motions cease, and this corresponds to minus 273 degrees Celsius on the Celsius scale. So we get all the remaining values by comparing the Celsius scale to the Kelvin scale. So the 0 degrees Celsius corresponds to 273 Kelvin. 100 degrees Celsius corresponds to 373 Kelvin. So any value on the Kelvin scale can be obtained by adding 273 to the Celsius scale. So when we add 273 to 0, we get 273 Kelvin. When you add 273 to 100, you get 373 Kelvin. Similarly, if you add 273 to minus 273 degrees Celsius, you get 0 Kelvin. So any value on the Kelvin scale can be obtained by adding 273 to the Celsius scale value. So 0 Kelvin was defined by Lord Kelvin as the temperature at which all molecular motions cease. That is, the speed of particles becomes 0. And as the speed of the particles becomes 0, the volume of gas is also reduced to 0. So absolute zero, that is 0 Kelvin temperature, is the temperature at which, number one, the speed of particles becomes 0, and number two, the volume of gas is also reduced to 0 at this temperature. A Celsius thermometer shows 25 degrees Celsius value. So what is the value corresponding to it on the Kelvin scale? So we know that we can get the values on the Kelvin scale by adding 273 to the value on the Celsius scale. So if we add 273 to this value, we get 298. Now what's the unit of this number? We know we are converting degrees Celsius to Kelvin. The unit of Kelvin is K. Remember, we always write degrees Celsius, which is right, but we never write degree Kelvin. The unit of Kelvin is K and not degrees Kelvin. So the value corresponding to 25 degrees Celsius on the Kelvin scale is 298 Kelvin. So these are the three physical parameters, that is volume, pressure and temperature that define the behavior of all gases.